Hey guys, this is the lesson 2.4 solving right triangles. So these are your yellow notes. Okay, so for this lesson, we're using what we learned kind of back in chapter 1 with Sakatoa, and then what we just learned last lesson in 2.3 using our calculator to find all of the sides and angles in a triangle. And this is kind of what we did back in geometry. You found missing sides in a triangle. So we have to remember like opposite, adjacent, and hypotenuse and how we find those in our triangle. And then we can go from there after we have that. So I went ahead and drew a triangle. I pretty much always draw, if we have to draw the picture like this, with C in the bottom. C is always your right, and I put A and B. It doesn't necessarily matter how you draw yours. It's good though if we have some consistency and kind of do it the same way every time though. So from there, I'll take what I was given and fill those in our picture. So we have that angle A is 34 degrees. And then side C, we know it's a side because there's no angle mark and it's a lowercase letter, is 12.7. So that would be the side C is across from the hypotenuse. So what we need to figure out is our other angle B. So we need angle B. And then we also need to know side A and side B. So it helps if you make a list so then you know what you need. We usually need to find 3 things, or we always need to find 3 things. So problems like this one are easier than the ones when we were given 2 sides like the next one, because it's really easy to find that third angle. Okay, so to find angle B, we just subtract the other 2 from 180. So 180 minus 90 minus 34 would give us our angle B, which is 56 degrees. So something to keep in mind for these problems is that I'd like you to only use those 2 numbers that you were given to find all of the rest of them. And that's because if you messed up on one of your other answers and then you use it to find another one, then that one's going to be messed up too. Or if you rounded and you use that to find another answer, then it'll just be a little off and your degree of error will just get bigger and bigger each time. So for this, obviously we know we subtracted right, so you could use this one, but if it's an answer that you had to round or you're maybe unsure if you did it correctly, don't use it to find it. You can find everything else just given the 2 things that you were given. Okay, so I'm going to label opposite, adjacent, and hypotenuse, so that way we can see if we're going to use sine, cosine, or tangent. So 12.7 is obviously the hypotenuse because it's across from the 90. The side that's across from the 34 is opposite, and the side that's next to the 34 and touching it is adjacent. Okay, so I'm going to find side A first. So for side A is opposite, and then we were given the hypotenuse. So we have opposite and hypotenuse, so that's sine. So we write our equation, sine of 34 equals the opposite side, which I'm going to put as an A, because that's what we need to find, over hypotenuse of 12.7. So if you remember how to solve these kind of equations, we just multiply both sides by the denominator to get that to cancel out. So then we would have that A is equal to 12.7 times the sine of 34. So from there, we just type that number in our calculator, or those numbers in our calculator, and see what we get, and that would be our answer for A. So in a non-backwards calculator, 12.7 times the sine of 34. So that means that side A is 7.1017. So in a backwards calculator, for this kind, you can just go backwards. So 34 sine times 12.7. Okay, good. We're almost done then. So we just need to find side B. So for side B, we have adjacent and hypotenuse, so that would be cosine. So we can set up our equation the same, except this time we have a B because we're finding side B and we're using cosine. So that means that side B would be 12.7 times the cosine of 34. And if you type that in your calculator, we get 10.5288. So I want to make sure you practice typing that in. So type it in and make sure you get the same thing. So that's it for solving triangles. So we just figure out what we need and then write a trig ratio equation to solve for. So let's check out the next example. So for this one, they give us two sides. So they told us side B is 12 and side C is 15. So this time we need to know angle A, angle B, and side A. So finding one thing is not as easy as it was on the last one because we can't just subtract from 180. But if we're trying to find this side A and we know two sides, then we can use the Pythagorean theorem to do it. So a squared plus 12 squared is equal to 15 squared. And then we can solve that to find angle A, or side A. So once you solve that, you would get that A is equal to 9. So now we have our side A. So to find angles, we set up our trig ratios just like we did for the last one, but this time we're finding theta instead, or A and B. So label everything that you have with hypotenuse, adjacent, and opposite, just like we did before. So if we're going to find angle A first, then we have adjacent and hypotenuse. So that would be cosine. So cosine of A equals adjacent over hypotenuse. So what do we do when we're trying to solve for an angle? Very good, we use the inverse. So angle A is equal to the cosine inverse of 12 over 15. So we type that in just like we practiced last class. One thing I would say is make sure, since we're doing division here, you close that parentheses. So we get that angle A is equal to 36.8699 degrees. So what trig function would we use to set up for angle B? Very good. We would use sine. So sine of angle B is equal to 12 over 15. And then we do the same thing that we did on the last one. So angle B is equal to the sine inverse of 12 over 15, which if we type that in our calculator, we get 53.1301 degrees. Okay, so make sure you write down any questions that you have. I want you guys to pause your video and try that example that's on the top. Okay, so we had to find one angle and two sides. So we just subtract from 180 to find that angle, and then we use tangent to find side B and cosine to find side C. So make sure you write down if you have any questions. Okay, so let's take a look at our word problems. So for these, it helps if you draw a picture, because then you can see what you have. And for these, we're not solving the whole triangle, we're not finding everything, we're just finding one specific side that they're asking for. So this one talks about Shelley, and she knows that she's standing 123 feet from the base of a flagpole. So here's my flagpole. Here's Shelley. And we know that they're 123 feet apart. So it says that the angle of elevation to the top of the flagpole is 26 degrees. And that her eyes are 5.30 feet above the ground. So that means when we draw our angles, we're going to have to do it from her eye level. Okay, so we're going to create our triangle up here from where Shelley's eyes would be. And that angle to the top of the flagpole is where the 26 goes. So our angle of elevation. So it's asking us to find the height of the flagpole. So remember that our triangle is only that part. So that's our x, but this part to the ground here is 5.3. So we can't forget about that when we're solving. And since this part here was 123, that means that this part is also going to be 123. So if we use SOHCAHTOA, we have opposite over here and adjacent down there. So we would use tangent to set up our equation. So the tangent of 26 equals x over 123. So x equals 123 times the tangent of 26. So when you type that in your calculator, we get 59.9911. So is that the height of the flagpole? Very good. That's only the height from the top of the flagpole to right here. But since we had 5.3 from the rest of it, we would have to add that 5.30 to that height. So our flagpole would actually equal 65.2911 feet. So I think that drawing the picture is the hardest part. So make sure you're using a pencil. I want you to pause your video and try to draw those two pictures. And when you come back, we'll talk about what they should look like, and then you can solve them. Okay, so for this one up at the top, this one was kind of complicated. So it said that the angle of depression from the top of the tree to a point on the ground is 15.5. So angles of depression go from a horizontal line down. Okay, so I started by drawing my tree and the ground, and then when it said angle of depression, I made a horizontal line, and I made a dash because we already kind of had the ground. You could have made it solid, it doesn't really matter. I was just trying to show that it wasn't actually part of our picture, but since the definition of angles of depression go from a horizontal line, we needed that horizontal line to show our 60.4. So then it says that the tree is 15.5 meters from a point on the ground, and now we're trying to find the height of the tree. So here's my triangle. I'm trying to find x. If you would have put the angle 60.4 over here, and then your x over here, you would have ended up with the same answer. And that's because these are parallel lines cut by a transversal, so those angles are congruent. Okay, so I want you to solve that equation by yourself. So go ahead and pause. Okay, so we used tangent and we got 27.2849. Okay, so let's take a look at our picture for the bottom. So this one says that we have a shadow, and the length of the shadow of a flagpole that's 25.2 feet tall is 27.65. Find the angle of elevation. So angles of elevation go from the horizontal up, so that's how I need to put my theta there. So go ahead and pause and solve and write your equation, and when you come back I will show you the answer. Okay, so using tangent we got that angle of elevation to the top of the flagpole is 63.3934. So remember to write down any questions that you have, and we'll talk about them in class tomorrow.